Hello, my name is Jesus Ferrand, and I'm the second team member for the Muncaster steam engine. And I will be going over the assemblies that I created, starting off with the pillow block assembly. The purpose of this part is to hold the crankshaft. The crankshaft's axle goes through the bearings that you can see on the image to the right. This particular assembly consists of 4 different parts. The main bearing block, which is divided into a top and a bottom part, a pair of screws of M4x10 screws, and the main bearing, which is split into 2 halves. To constrain this assembly in CATIA, this was simply done by applying a coincidence between the axes of symmetry of the screws and the holes of the main bearing block. Similarly, the bearing was constrained in the same way. To fully constrain them, I applied contact constraints between the appropriate surfaces of the screws and the main bearing block. The pillow block assembly is later reused to make the frame assembly, which has the purpose of holding the crankshaft above the base. This particular assembly consists of the pillow block assembly, 2 M4x10 panhead screws, and a main upright frame. 2 of these assemblies are used to make the steam engine. In CATIA, to fully constrain these parts to form the assembly, again, all I had to do was apply coincidence constraints between the screws and the holes of the pillow block assembly and the holes on the top of the main upright frame. Next is the main frame assembly, which together is also known as the bottom assembly of the entire engine. It consists of the previously shown base assembly and 2 copies of the frame assembly. The base and the 2 frames are joined together by means of screws. These are also M4x10 panhead screws. The same constraint method as the 2 previous assemblies was used to fully constrain this part. This bottom assembly is where the cylinder and the crankshaft go into. The purpose of this entire assembly is to quite literally hold the engine together and provide a support for it. Finally, we have the cylinder assembly, which has the purpose of quite literally containing the steam that delivers the power to the crankshaft. Okay, this assembly fits into the previous bottom assembly by means of the central beam that comes out of the right side of the assembly. This fits into the cylinder pedestal to the right, the large pedestal that you could see previously on the base. To the left, there's also a cylindrical feature that has a hole in it. The spindle, there is a little black spindle that fits into the smaller pedestal, goes through it, and then into the circular feature that you can see to the left. That way, that's how this cylinder assembly is held in place. This allows it to rotate to make the engine's motion possible. This particular assembly consists of 5 different parts. It consists of the main cylinder block, which is by far the largest piece of this assembly. It has several circular features, both internal and external. It has fillets and several holes. It has a total of 8 holes. Now, to fully contain the steam, it needs 2 covers. There's a top and bottom cover. The covers are joined to the cylinder block by means of 8 screws. This time they are M4x6 panhead screws. There's a final fastener on the top, which is a hexagonal nut. It is threaded on the inside and outside. This is where the piston assembly fits into. Conclusion and evaluation. The project was successful, as all parts were sketched with relative ease and quickness. The assemblies were simply put together, as the parts had very well defined fittings. The hardest aspect of the project was the drafting of the individual parts, as they had many features both internal and external. Team communication was good. However, as a team, we could have exercised better time management, as a great deal of our project was done nearing the deadline.